A warm welcome. This is Control Systems course, lecture 3.3, focusing on polar plot. Already we have discussed about the Bode plot of representation, and now we are going to see about the polar plot representation. And polar plot is nothing but the plot which is drawn between the magnitude of the open loop transfer function versus its phase angle. On the polar coordinates we have to draw it, and here the value for omega can be varied from 0 to infinity. The polar plot is otherwise called Nyquist plot, and it's a graphical method for determining the stability of the feedback control system. By using this polar plot, we can represent the polar behavior, that is the behavior of the graph with respect to magnitude and phase angle correlation. A simple way of finding out the starting and ending of the polar plot is through the minimum phase system, where the type number is used for the representation of the starting point of the polar plot, and the order of the system can it can be used to represent the end of the polar plot where it has to stop. Normally we know what is order. It is the maximum power of the S value in the denominator polynomial of the transfer function, and type number is nothing but the number of poles available or present in the origin. So let us consider the type number of the system. It may be type 0 system, type 1, type 2, type 3, etc. Here the logic is, if it is a type 0 system, then the polar plot will start from the right hand side of the x-axis. If suppose it is type 1 system, then it will start from the bottom. If it is type 2 system, it will start from the left hand side of the axis. And if it is type 3, it will start from the top. Similarly, type 4, type 5, type 6, etc. onwards. And here, if it is having an order of 1, if it's a first order system, then obviously the system will end only in this coordinate, that is the quadrant, in this quadrant. And similarly, if it is a second order system, then it will end in this third quadrant. If it is a third order system, it will be ending in this second quadrant, and if it is a fourth order system, the polar plot will end in the first quadrant of the axis. So this is how the representation is, and then it can be increased if it is 1, 6th order, 7th order, 8th order, etc. This is how the representation. After drawing the polar plot, we can verify whether the start and end of the system is correct or wrong with the help of this manipulation. Or in general, if we are asked to draw a polar plot, we can easily represent it with the help of the type number and order of the system. And regarding the rules which are used for drawing the polar plot, first step is S value has to be replaced by j omega. We have to calculate the magnitude and the phase of g of j omega into height of j omega, that is the loop transfer function. Then we have to substitute omega is equal to 0. For omega is equal to 0, what is the magnitude and the phase value of the loop transfer function? Till the omega value, what and all we need. But the main thing is we have to include all the corner frequencies. At first itself, we have to find out the corner frequency of the given loop transfer function. So all those corner frequencies have to be definitely included, and then we'll have a maximum limit, or else in this case also we can have a low corner frequency and a highest corner frequency, which we assume, and we can draw a graph between that frequency values. And now we can check whether the polar plot intersects the real axis by making the imaginary term of g of j omega, h of j omega equal to 0, and we can find the value of omega. Similarly, we can check whether the polar plot intersects the imaginary axis by making the real term of g of j omega, h of j omega equal to 0, and find the values of omega. Now, for clearly drawing the polar plot, the magnitude and the phase angle and the corresponding values of omega has to be considered. Let us see, this is how the graph will be. Here we have found out the gain margin and phase margin. So before that, let me say you here the graph will be represented in two different forms. One is circular form. It will be having circular, I mean this is one circle, but it will be having n number of circles. There will be more number of circles, as well as there will be more number of straight lines at defined angles. The lines will be drawn only at defined angles, that is 0 degree, 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, 60 degree. As such, it will be consisting of defined angled straight lines and this circles. So what we used to do is we consider this circles for representing the magnitude of the loop transfer function and this straight line as the particular angle. For example, this is a 0 degree line and next this is a 90 degree line. So between them 45 degree line will be there. Here it will be 10 degree, 20 degree, 30 degree, 40, 50, 60, 70, 80. Similarly, we'll have straight lines. So the straight lines will be representing the angles and the circles will represent the magnitude, of course. So the condition is for drawing the polar plot, we have to consider a unity circle because we already have 180 degree here. We know about gain margin and phase margin calculations. The same is going to be considered here, but in certain different manner. That's all. So here already 180 degree line is there, right? So we can find out the gain margin in that sense. What we are in need of is in Bode plot, we'll consider the unity as a magnitude. So what unity, or in decibels we'll consider the zero value. Here we are going to consider a unity circle, that is in the magnitude, among the magnitude, let us consider the magnitude value to be 1 for one condition. Here what we'll do is we'll represent the plot between, for example, for a certain omega value, we'll have the representation between this circle value, what is the magnitude, and at that magnitude, what is the angle. With the help of that, we have n number of points, and those points will be connected together to form this plot here. Now, we have to find out the gain margin and phase margin after drawing the plot. So let us take the gain margin first. So in case of gain margin, how we are going to calculate the gain margin is 1 divided by magnitude value. 1 divided by magnitude value. Now we have to find out this magnitude value. How we will calculate this magnitude value is here, this is the line, I mean this is a parallel vertical line and this is a starting point, or else it is an ending point for the polar plot. We can see that this polar plot is cutting the 180 degree or minus 180, whatever it is, the 180 degree line at this point. So let us mark this point and we have to calculate the difference between this point and this vertical line. So this magnitude is based upon the circular value what you have taken. If it is 0.1, 0.2, 0.3, then here also we have to calculate as such. If suppose it is taken as 1, 2, 3, and then accordingly we have to calculate this value. So this magnitude is determined based upon the scaling what you have taken, and GB value can be found out. So the thing is, the polar plot has to cut the 180 degree line. From that point, you have to find out the value based with the reference line. And next, for finding out the phase margin, what we have to do is we have to consider the point where the curve, where this polar graph cuts the unity circle. So at point A, we can see that the polar graph is cutting the unity circle. Now to calculate the phase margin, we are in need of an angle. So what we have to do is, we have to draw a line from the origin connecting this point A. Now we can find out the angle here. From 0 degrees, what is the angle? From 0 degree, what is the angle of this line? If we find out this value has to be added to 180 degree. automatically you'll get the phase margin. In this case, it will be a positive gain margin as well as positive phase margin because the polar curve or polar plot is within the unity circle. This is one point. You can see here that the unity, the graph is outside the unity circle. It is going outside the unity circle. In such a case, we can see here that this is the gain margin value calculation. We have to find out GD. We can see that the 180-degree line is cut by the polar graph outside the unity circle. So this is your magnitude value. So 1 divided by that value will give you the gain margin. Next is, we can see the polar graph is cutting the unity circle at this point. You draw a straight line here and you have to measure the angle between the 0 degree and this line. You'll get a larger angle plus 180 degree. If you substitute, you'll get the negative gain and phase margin in this case. So this is how we'll be calculating the gain and phase margin with the help of a polar. Already we have GB is equal to 1 since it's a unity circle. So it can be considered as 1. So 1 by GE will give you the value for K with the help of phase margin. This is how the polar plot will be represented, and the gain margin and phase margins have to be calculated, and how the unknown parameter K value can be calculated using gain margin and phase margin. Thank you.